Okay, page 26. I'm just going to give you an overview in 25, actually. 25 has all seven quadrilaterals that you're expected to, you know the name, and you're supposed to also know the properties of them. I tell my students, rule of thumb, if you know 3 properties per shape, you're doing pretty good. You're doing pretty good. So this is what I mean. So what are the 7? These are 4 here. These are related. I call these are related. Then you've got your kite. That's 5. Right trapezoid, isosceles trapezoid. So these are your 7 right here. And you might say trapezoid is there by itself, Mr. Dirksen. Isn't it 8? I would just say that these are trapezoids, but there are specific names for each one of those. So what are 2 properties of a parallelogram, let's say? You should know that it's got 2 pairs of sides that are congruent, that measure the same. It's got 2 pairs of parallel sides, right? That's 2 properties already. What else do we know? Well, I know, but I've taught this many, many times, but I know, for example, that their diagonals bisect. They cut each other in half. That might be something unique that you want to add. What do we know about the diagonals? What makes the diagonals unique when we talk about the rhombus or the square? What if I had like $100, like hypothetically speaking, I had $100, and I said, what do we know about the diagonals on these 2 shapes? What's so unique about their diagonals? Yes? They're equal here, but they're not equal there. There's something that both of these, like you look at your notes, go to 26, wink, wink. They're perpendicular, right? So these 2 are unique in a sense that their diagonals are perpendicular. But could you say that they are all bisecting? They all bisect each other, the diagonals? Yes, they all do. These 2 would have diagonals that are the same, right? These 2, the diagonals measure the same. Whether you go from this corner to that corner or this way, they are the same. Same with this one. These 2 are slanted. You see how they're slanted? So these 2 are going to have a long and a short diagonal, right? So that's something to keep in mind. So, but they all bisect each other. That's something that they all share in common. They all share in common that they've got 2 pairs of parallel sides. Okay? They all share in common that the opposite angles are congruent. They all share that property. What's so special about the rhombus and the square in terms of the side length? How are they related? They all have all 4 sides measuring the same. That's how they are related. So things like that, they would expect you to know. What is the similarity? Listen to this one. What's the similarity between a square and a kite? What do they share in common? I don't know. It's been a weekend, a long weekend, Mr. Dirksen. I don't know. Their diagonals are perpendicular. Okay, that's something that they share in common. Same with a rhombus and a kite. Their diagonals are perpendicular, so that's something that you might want to add. I think that's maybe a little bit too much I think for me to expect for you to see like, oh, what are the similarities? How are they different? Might be a little difficult to do, but if you have the items that are on 26, what I put down true for all, these properties are true for all of these 4 shapes that are on this page, right? All of these things are true for all of these 4 quadrilaterals. Quadrilateral stands for 4 sides, right? So that is true. And so I kind of told you a little bit like what's unique about a rectangle, for example. The fact that all angles are 90s. That's unique about a rectangle. That the diagonals are exactly the same. They measure the same. What's unique about a rhombus? And if you wrote this down, you kind of have enough, right? What's unique? The diagonals are perpendicular. All sides are the same. That's unique about a rhombus. What's unique about a square? All sides are equal. the diagonals are also perpendicular. So there are things that are shared and some things that are very unique just to one shape. Okay. Let's go to our, on page 27, we've got the two trapezoids. The right trapezoid is quite boring, okay? Isosceles trapezoid. Think of an isosceles trapezoid as a chopped off isosceles triangle, right? The top part here has been, it's a truncated shape. That's the fancy term, truncating. You cut off the top part, okay? Remember that the diagonals do not bisect. Do not make the mistake to think, oh, if it's 5 from here to here, it's 5 from there to there. That's not true, okay? It's not true. And the kites. We talked about the kite. So you have to have at least the names of these guys, okay? At the very least, you have to have the names. And when you recognize the shape, you should be able to call it what it is, okay? And there we go. So let's put this to the test, okay? On page 28, I will do a couple, and then you'll do a couple. Sure. No. Lights are all working. No concerns. Let's draw a kite. It says sketch the following and identify two properties. I would like you to be able to make 3 versions of each shape. What do I mean by that? Just hear me out. Sometimes the province has said, draw a kite and just give me 2 properties about it. So you either use markings or you use statements. It's up to you. Sometimes they say, identify everything that is equal about them. Like, what is equal about them? Then you need to be able to do that. Okay? So let's draw a kite. I hope you know what a kite looks like. I think of 2 isosceles triangles, but they're not the same. So maybe the top is usually the shorter one, and then you extend the bottom like this. Okay? And so let's label something. I don't care what you label. Let's talk about the sides. We know that this side measures the same as that side right there. So they are the same. We know that the long sides here, they're also the same. So we've talked about one property. Let's write it down. 2 pairs of congruent sides. What else can we talk about? Well, if you recall, this angle measures the same as that angle. Okay? So you can say 1 pair of equal angles. Write it out if you don't know. Okay? Or let's talk about a different, so let's imagine, right, your neighbor sketched this. Your neighbor would get 2 out of 2, right? This would get 2 out of 2 because you've identified 2 properties. Let's do another one. I'm going to talk about the diagonals because that's something that sticks, okay? So I will make the short diagonal and the long diagonal. What do we know about the diagonals? They meet at a 90. Okay. Property number 1. I will say that diagonals are perpendicular. You need to know notation for that, right? So if that bothers you, you just write diagonals meet at a 90-degree angle. That's fine. There's no problem with that. And another one is that the short one bisects. Okay, short diagonal bisects. Those are 2 properties. And now I'm going to use a combination of the two. I don't know. Just have to be a little careful with markings. Let's talk about the side lengths. These are the same. These are the same. And I will throw in diagonals. And I'll just make a 90 there. Okay, so diagonals bisect, are perpendicular, and there's two pairs of equal sides. That's what I mean with three versions. Try to do it, try to mention, make it look different. Try to make your diagram look different, that in each case you're highlighting something slightly different. That's just going to ensure that you know enough properties about it. If you can't do three, that's fine. Just do one at least, at the very least. Okay. So I'm going to ask you to try 28 all the way to, for now I'm going to stop you at 31 if you get there. If you stop. So it's not all the sketching. Page 28 to 31. Let me read the room first. It's boring. There's not much you can do with a right trapezoid. Okay? It's kind of like my jokes. Okay? There's not much you can do. A right trapezoid, I just hope that you would know that it looks like this. And that it has two 90s there. And it's got one pair of parallel sides. So two right angles and one pair of parallel sides. That's it. You can't do more with that one. That one is like, that's all you've got. Parallelogram. That one has tons of versions, guys. I just need you to know that it looks like this. It's a slanted rectangle. So we're going to do that. We're going to do another one at least. So let's stick to the sides. I know that this side measures the same as the top, and I know that this side measures the same as that. So two pairs of congruent sides. What else do we know about the sides? It's called a parallelogram. Parallel, right? It should tell you this one is the same. They will never meet. This one has two arrowheads. Okay, two pairs of parallel sides. What about this one? I will do this. I will talk about the diagonals. I know that they cut each other in half, so you can make a dot right at the center where they cross. So these stretches here will be the same. That's the long diagonal. And these shorter diagonal, like these shorter stretches, are also going to be the same, but you have to have different markings there, or else you're saying they're all the same. But they're not. It's just from here to here and here to here. And if you really want to make your point, if you go A, B, C, D, okay? If you don't understand what the markings are trying to say, let's put in the middle, let's put A, B, C, D, E. Let's call the center point E. What I'm saying is that AE is the same thing as EC. And that BE is the same thing as ED. You can get creative. Oops. You can get creative on how you want to express the properties. Okay. What does this all say? It says that diagonals bisect. This is property number 1, by the way. That's not 2 properties. That's just 1 property. What else can we say? We can talk about the fact that these 2 lines are parallel and these 2 lines on the side are parallel. 2 pairs of parallel sides. Yeah, 1 sec.